Hello everyone and welcome to the Safety Artisan home of safety engineering training. And today we're going to be moving on to the subject of operating and support hazard analysis. So this is, as it says, task 206 under the standard. Unfortunately that will confuse people if I call it OSHA, let's call it ONS. So the purpose of ONS hazard analysis is to identify and assess hazards introduced by those activities and procedures, and also to evaluate the adequacy of ONS procedures, processes, equipment, facilities, etc., to mitigate risks that have been already identified. So we're not going to go through every little clause of the standard. That would be pointless. And as we've already said, it's to identify and assess those hazards which are introduced by operational and support activities and procedures, and evaluate their adequacy. And of course, this is a military standard, so we assume a military system, but not all military systems are weapon systems by any means. Not all are physical systems, so there may be inventory management systems, management information systems, all kinds of stuff. Does that create any hazards or introduce any hazards? And how do we mitigate? So let's move on to the task description. So we're assuming an American style life cycle for a big system here, and EMD comes after sort of concept and requirements development. And so we're suggesting that OSHA can wait until then, which is fine in general, unless you've identified any particularly novel hazards that will need to be dealt with earlier on. And as it says, it should build on design hazard analyses. But we'll also talk about the case later on when there is no design hazard analysis. And the ONSHA shall identify requirements or alternatives for eliminating hazards, mitigating risks, etc. And this is one of those tasks where the human is very important, in fact, dominant, to be honest, both as a source of hazards and the potential victim of the associated risks. So a familiar triad, and I know I keep banging on about this, but this really is fundamental to bounding and therefore evaluating safety. We've got to know what the system is, what we're doing with it, and the environment in which we're doing it. It's frighteningly easy to produce a system that needs so much maintenance, for example, or support activity, that it is unaffordable. And lots of military systems, and must be said government and commercial systems in the past have come in that required enormous amounts of support, which soon proved to be unaffordable, or no one would sign up to the commitment required. We need to look at unplanned events, so not just designed in things, but things introduced. So do make an effort to get hold of that information if you can. Maybe a trade association or some wider pan organisation body can help you there. Secondly, changes needed in requirements, and then we've also got to communicate to people the hazards associated with the system, so warnings, cautions, and whatever special emergency procedures might be required associated with the system. And again, that's something that we see reinforced in law and regulations in many parts of the world. It's accepted good practice all across the world. So moving on, we also need to think about, well, how are we going to move the system around and the associated spares and supplies? How are we going to package those? Again, we're thinking about a human-centric approach here. You can't just ignore stuff because it's GFE or it's off the shelf. It doesn't mean that it can never go wrong, far from it, particularly if we're putting stuff together that's never been put together before in a novel combination or in a novel environment. Something that might be perfectly safe and stable in an air-conditioned office might start to do odd things in a much more corrosive and uncontrolled environment, even if it's only to shut it down or to get it back into a safer state or a safer environment. We've got to think about all of those nuances. And then, because we're talking about support as well, we need to think about related legacy systems, facilities and processes which may provide background information. And an absolute classic on this with military and non-military systems is a system gets designed, it goes into test and evaluation, and we discover that assumptions that were made during development don't actually hold up. The real world isn't like that, or whatever it might be. But when you start making assumptions, the truth is that it very often goes adrift. Okay, let's talk about reporting. Just a couple of slides here. Again, we might assume that everybody knows what they are, but it's important to put them in. All the different things that have to be brought together, we need to make sure that they join up again. So hazard analysis methods and techniques. Okay, what data, both qualitative and quantitative, have we used to support the analyses? That all needs to be declared. So if there are changes, if we don't have this kind of information declared, we can't assess the impact of changes. And it gets even more difficult to keep up with what's going on. And then hazard analysis results, and we also need to provide warnings, cautions and procedures to be included in maintenance manuals, training courses, operator manuals, etc. So we're probably going to generate an awful lot of data out of this task, and that needs to be provided in a suitable format. And that leads us neatly on to contracting. There are good reasons for doing that sometimes. Also, there are bad reasons, but I'm not going to talk about that in this session. So there's a lot of nuances in there to be considered. But just sticking to this task, identification of functional disciplines. Who do we need to get involved in order to do this work properly? So it's likely that the safety team, if you have one, may not have relevant operating experience or relevant sustainment experience for this kind of system. We need the discipline specialist to get involved. Typically your integrated logistics support team, your reliability people, your maintainability and your testability people, if you have those disciplines. Or maybe you're calling them something else, it doesn't really matter. So we need to know what are the reporting requirements, what, if any, analysis methods and techniques do we desire to be used, and when, etc., considering the hazard tracking system, etc. And then the client may also select or specify known hazards, known hazardous areas, or other specific items to be examined or excluded, because maybe it's being covered elsewhere, or we don't expect the contractor to be able to do this stuff. And in fact, these days, maybe the majority of programs that I am seeing are mostly non-developmental. We need to think about legacy and related processes and the hazard analyses associated with them if we can get them, and they should be supplied to whoever's doing the work, and the analyst should be directed to review them and include lessons learned. And then, reinforcing the previous point about the hazard tracking system, how will information reported in this task be correlated with tasks and analyses that are being done maybe elsewhere or by a different team? And the example here is 207 health hazard analysis. I'll talk a little bit about the linkages between the two later. Sometimes they don't even talk to each other. That's the culture in different organizations. You don't see airline pilots hanging around with baggage handlers very much. And again, you've got to tie everything in with them. So there's going to be lots of interfaces in this kind of task that have got to be managed. And then finally, what risk definitions and what risk matrix are we using? Now, I've picked an Australian example here. So task 206 ties in very neatly with Australian WHS requirements. Actually, I suspect Australian WHS requirements have been strongly influenced by American OSHA and system safety practices. Because in Australia, we are heavily influenced by the US approach. So this standard and our legal requirements in Australia and in many other states and territories, let's be honest, do tie in nicely with the standard, although not always perfectly. Got to remember that. So we do need to focus on operations and support activities, be they operators or maintainers, suppliers, other kinds of sustain, and I would say in virtually all developed nations. So this is a very important task for achieving compliance with the law and regulations. And it needs to get the requisite amount of attention. But if you don't have any steers on what to do, this will help you. Now, the other side is there's the operator side. So we're going to be seeing potentially a lot of human factors type techniques being relevant. We can think about hierarchical task analysis. Those are going to link together quite well. There will also be things like workload analysis. I'm going to be putting on a series on human factors techniques in cooperation with a specialist in that area. It is worth saying that, let's go back up. I was just checking and say that it's later, but equally there are a vast range of operator roles in industry, in chemical plants, various specialist operating roles where there's an industry-specific approach to doing things, or indeed the general approach may be left up to whoever is developing the system we're covering here. You've got to get the specialist knowledge in to do it well, but also in many other walks of life as well. So we may find ourselves evaluating a system where very little technical hazard analysis has been done because there are no developmental items, and it's even difficult to do analysis on legacy or a COTS system because we cannot get the data to do so. Perhaps we can't get the data for commercial reasons, contractual reasons, or maybe we've got a legacy system that was developed in a different jurisdiction, and whatever information is available with it just doesn't fit the jurisdictional regulatory system that we've got to work in where we want to operate the system. And we will very definitely need to do some system requirements hazard analysis, task 203, to understand what we need to do for a particular system in a particular application, operating environment, and regulatory jurisdiction. So we're always going to have to do those. And we may well have to look at the integration of COTS things and do some system level hazard analysis. So yeah, we're definitely going to need to do the early analyses, and in fact, the client and the end user representatives should be doing 201, 202, and 203. Now, having said that, I've mentioned already that task 206 can be very broad in scope and very wide-ranging, and there's a danger that we will turn task 206 into a bottomless pit into which we pour money and effort and time without end. So we can't, for most systems, we cannot afford to just do ONSHA blanket across the board without any discernment or any prioritization. It's going to be easier to make a SFARP or a LARP argument that way anyway. So let's not do analysis for the sake of doing analysis. Also, there's a strong synergy between the later tasks in the 200 series. And also there can be a strong linkage between task 2010, which is environmental hazard analysis. And very often there's a lot of overlap between them. For example, hazardous chemicals that are dangerous for humans are often dangerous for animals and plants and watercourses and so on and so forth. Certain chemicals may be quite benign in certain circumstances, and they only become dangerous, let's say, after an emergency. So that's the commentary that I have on task 206. However, this presentation and my commentary, etc., are copyright the Safety Artisan 2020. Now, for more lessons and resources, please do visit the safetyartisan.com.